Elon Musk's long-awaited 2026 Tesla superelectric plane has finally been revealed, and the excitement surrounding it feels unlike anything we've seen before in modern aviation. For decades, regional air travel has been both a blessing and a curse. On one hand, it provides a faster alternative to driving, but on the other, it has remained inconvenient, expensive, noisy, and unreliable. If you've ever taken a short-haul flight in the United States, you already know the frustrations. A simple trip of 400 to 500 miles still eats up 6 to 7 hours if you choose to drive. But even if you book a plane ticket, you face the reality of high fares. Outdated turboprop aircraft that rattle your eardrums with noise levels pushing 90 decibels. An on-time performance that leaves much to be desired. Studies show that only about 73% of these flights arrive when they're supposed to. Delays caused by aircraft needing maintenance or late arrivals are common, meaning passengers rarely enjoy stress-free travel. For something that should make life easier, regional flying too often becomes just another source of headaches. This is exactly the problem Elon Musk believes the Tesla superelectric plane is designed to solve. He and his team at Tesla looked at the flaws of regional aviation and set out to design a machine that flips the equation on its head. Instead of noise, imagine silence. Instead of expensive tickets, imagine more affordable fares. Instead of frustrating delays, picture a system built for reliability and speed. The solution they propose is not a simple tweak to existing planes, but rather a complete reinvention of how regional flights can and should work. The 2026 Tesla superelectric plane is Musk's radical answer, and it brings with it features that sound almost too good to be true. One of the most striking aspects of this new aircraft is the way it approaches energy. Instead of requiring long ground times for refueling or recharging, Tesla has developed a system of hot swappable energy packs. This means that once a plane lands, the used battery modules can be removed and replaced with fresh ones in just a matter of minutes. No more waiting around for slow refueling trucks or charging cables. Just like a pit stop in Formula One racing, the turnaround time is cut dramatically, making it possible to keep planes in the air far longer than today's fleet ever could. That efficiency translates directly into more flights, lower operating costs, and most importantly, reliable schedules for passengers. On top of that, Tesla's plane doesn't rely on a single large jet engine like traditional designs. Instead, it uses a distributed electric propulsion system made up of multiple electric motors. The beauty of this approach is threefold. First, it keeps noise levels far lower than conventional turboprops. Instead of enduring deafening cabins, passengers will experience a quiet hum, making it possible to hold normal conversations without straining your voice. Second, the redundancy offered by multiple motors means that even if one unit fails, the plane can continue its journey without disruption. Safety and reliability get a significant upgrade because of this architecture. And third, electric motors are far simpler to maintain than combustion-based engines, which means less downtime for repairs and lower maintenance bills for operators, for travelers. This isn't just a technical improvement. It's a revolution in the experience of flying. Imagine being able to travel coast to coast or hop between regional cities without being subjected to endless security lines, mechanical delays, and outrageous ticket costs. With Tesla's design, regional air travel suddenly becomes not just a mode of transport, but a stress-free part of life. It's the type of vision that explains why so many people are following these announcements closely and why Elon Musk's name continues to dominate headlines whenever a disruptive innovation is unveiled. The cabin itself is where many of the most human-centered changes are found. Rather than stuffing in as many seats as possible, Tesla has designed a flexible interior that can be arranged to carry anywhere from 4 to 12 passengers, depending on the mission. For family trips or smaller groups, layouts of 4 or 6 seats provide plenty of comfort. For shuttle services or business operations, larger layouts maximize efficiency without sacrificing ease of use. The designers paid special attention to accessibility and comfort for all ages. One-to-one seating arrangement paired with a central aisle about 20 inches wide allows passengers to move in and out smoothly. Something particularly important for older adults or families traveling with young children: seat pitch. or the distance from one row of seats to the next, has been set at around 33 to 34 inches. This strikes the perfect balance between comfort and practicality, giving enough legroom for short flights while still ensuring the cabin remains efficient in layout. Each seat itself measures about 18 to 19 inches wide, which is more than adequate for flights lasting between 45 and 90 minutes. Typical range for regional hops, this plane is built to dominate. In a move that may surprise those accustomed to conventional aircraft, Tesla has chosen to eliminate bulky overhead bins. Instead, luggage is stored beneath the seats and in a rear compartment. This keeps boarding and deplaning simple, reduces cabin clutter, and streamlines the entire process from arrival at the gate to takeoff. But Tesla isn't just stopping at cabin layout. Another key feature is how the propulsion system directly addresses some of the worst aspects of current regional aviation. Turboprops and small jets are notoriously loud not only outside the aircraft but inside as well. Cabins often measure 85 to 95 decibels, which is equivalent to being next to heavy traffic or even a lawnmower for the entire flight. Prolonged exposure to that level of noise can cause fatigue and stress, and it robs air travel of any sense of relaxation. The Tesla plane, by contrast, is engineered to dramatically cut those noise levels, allowing passengers to enjoy a calm and quiet environment. This makes short flights far more pleasant and potentially attractive to travelers who otherwise might avoid flying altogether. Maintenance has always been another huge hurdle for airlines, particularly in the regional sector where margins are tight. A single unscheduled engine repair can delay an entire day's worth of flights. With Tesla's design, however, the distributed propulsion system and simplified electric motors/maintenance requirements. Electric motors have fewer moving parts, no oil systems, and far less wear and tear overall compared to combustion engines. This reliability ensures fewer delays caused by mechanical issues, which in turn leads to more predictable flight schedules. For passengers, that means fewer misconnections, fewer cancellations, and a smoother travel experience overall. Of course, propulsion and energy systems are only part of the equation. The energy core of the plane is also built with both speed and longevity in mind. Fast turnaround is essential for commercial viability, which is why the hot swap battery system is such a breakthrough. Rather than grounding a plane for hours, Tesla envisions dedicated service hubs where planes can roll in, swap out depleted modules for fully charged ones, and be airborne again in record time. These packs are designed for long life cycles, meaning they can be charged and discharged thousands of times before needing replacement. Combined with Tesla's deep experience in battery technology, the result is an energy backbone that supports rapid operations while remaining cost-efficient for airlines. Safety is another area where Tesla brings its expertise. Advanced avionics systems are being integrated into the aircraft to ensure smoother navigation, better situational awareness, and enhanced automation for pilots. Just as Tesla cars introduced autopilot features to improve road safety, the aircraft is expected to benefit from similar philosophies in aviation. The goal is to provide pilots with tools that reduce workload, improve precision, and allow flights to run calmly and consistently. Passengers benefit not only from smoother rides, but also from the reassurance that they are traveling in one of the most technologically advanced and safest aircraft in the skies. Airports themselves are part of the challenge too. Many regional airports are small and lack the infrastructure of major hubs. Servicing planes quickly and safely in these environments is critical, which is why Tesla has emphasized simplicity in the servicing model. The modular battery system is easy to handle, and the distributed propulsion units require less specialized maintenance equipment. This makes it possible for even smaller airports to operate the Tesla plane efficiently without the need for massive new investments. The result is a network that can support frequent regional flights across the country, opening up more communities to fast, clean, and affordable air travel. The bigger picture here is what this means for regional travel as a whole. Today, driving long distances remains the default option for millions of Americans simply because the alternatives are not attractive. Regional flights are noisy, expensive, and often unreliable, leaving travelers to endure hours in traffic instead. But with Tesla's super-electric plane, that equation changes. The promise is an aircraft that flies just as fast as current models, while being quieter, cheaper to operate, and more dependable. It's not just an incremental improvement. It's a shift that could redefine how people move between cities and regions. For airlines, the economics are compelling. Lower maintenance costs, faster turnaround times, and